Hello girls, I hope you're staying safe at home. To continue with the water chapter, if you remember in the last upload we were talking about solutions. So today we move on to solubility. Now what do you mean by solubility? To define solubility, it is defined as the amount of solute that dissolves in 100 grams of solvent to form a saturated solution at a particular temperature. So this is your definition of solubility. But actually what does it mean? How much of the solid will dissolve in 100 gram of water to form a saturated solution at a particular temperature is known as solubility. Now, different substances dissolve to different extents in the same volume of a given solvent. Like for example, the mass of sodium chloride and potassium nitrate, if you take 100 grams of water at 40 degrees Celsius dissolves 36.5 grams of sodium chloride, and 100 grams of water at 40 degrees Celsius dissolves 63 grams of sodium nitrate. So which one is more soluble? Naturally, which is 63 grams, that is potassium nitrate. So the solubility of potassium nitrate is more than that of sodium chloride. So that is why different substances, they have different solubilities. Now, the solubility of a solute in a particular solvent at a given temperature is equivalent or equal to the maximum number of grams of the solute to turn that 100 grams of solvent into a saturated solution at that given temperature. Okay, now a substance that has negligible solubility. Negligible means it dissolves but so less that you can even ignore it. Okay, so such substances are known as insoluble. For example, silver chloride has a solubility of 0.000015 grams. That means so less of it dissolves that you can ignore it. But on the other hand, that some substance that has more than negligible but less than high solubility is called sparingly soluble. That means more than negligible but less than high solubility, then it is known as sparingly soluble, means little bit is soluble. Example, calcium hydroxide, which has 0.17 gram as its solubility. Okay, and a substance having high solubility like sodium chloride is called soluble. Okay, now there are different factors which affect solubility. Okay, so how much of the solute will dissolve in a liquid or solvent depends on the following three factors. So first is the size of solute particles. Smaller the size of the solute particles, greater is its surface exposed to the solvent, so greater is the solubility. Now for example, if you take sugar and glucose, which one has smaller size? Naturally glucose. So which one will dissolve faster? If you put one spoon of glucose and 1 spoon of sugar in 2 glasses of water, you will see that the glucose will instantly dissolve because it has smaller particles. But sugar, you have to stir until it dissolves. So smaller the size, greater is the solubility. Next is stirring. Okay, when you stir the water or the solvent, it will bring the solvent in contact with the solute, and so it increases the rate of formation of solution. Okay, now next is temperature. The solubility of a gas in a liquid, it decreases with rise in temperature, because in a gas, what happens when you heat it? The gas will escape away from the solvent. But the solubility of most solids in water increases with rise in temperature. Now if you take for example potassium nitrate, you will see that at 20 degrees Celsius 31.6 grams of it dissolve, but if you heat it to 60 degrees Celsius 108 grams will dissolve in it. So you can see how the rise in temperature has increased its solubility. So all these factors affect solubility, because in the process of dissolution, that is turning of solute into solution or dissolving, the particles of solute merely occupy the spaces between the particles of the solvent without undergoing any chemical change, because forming a solution is not a chemical change, it is a physical change. Now, variation in solubility of a given substance with temperature, okay, can be shown by means of, a graph. So here you can see how the solubility curve, you can see it as a line graph that plots changes in solubility. So this side solubility is shown, you can see here, okay, and on this side what is shown, temperature in degrees Celsius. So as you move up, the solubility increases. As you move this side, the temperature increases. So here, if we look at this graph, you can see substances like sodium nitrate, okay, potassium nitrate, potassium bromide, okay, and then we have potassium chloride. You can see that if there is an increase in temperature, their solubilities are also increasing. From here it is going right up. Potassium nitrate shows the highest curve, okay. So here it is rising, the solubility is rising as the temperature is rising. Now if you look at the solubility of sodium chloride, so this is sodium chloride. So see, it has increased only little bit, okay. So sodium chloride increases only a little with increase in temperature, okay. Now if we look at hydrated calcium sulfate here, it increased little bit until it reached 40-60. Then after that, see, it dropped down. No more, it does not dissolve in water. So solubility of hydrated calcium sulfate shows a decrease after attaining a little bit of increase when there is a rise in temperature, okay. Similarly, there is ceric sulfate, slake lime, which shows similar decrease in solubility, okay, when it is kept on increasing. Now we move on to anomalous solubility. Now anomalous solubility means something which you cannot explain. There are some salts whose solubilities first increase and then decrease with rise in temperature. Example is Glauber salt. Remember what is Glauber salt? It is hydrated sodium sulfate, okay. So here you can see we are heating it, the solubility will increase until which temperature? 32.8 degree Celsius. Then after that, you see it has dropped down, because here from hydrated crystals it turned into anhydrous. It does not have any water of crystallization now, okay. So why? Because sodium sulfate is hydrous below 32.8 degrees Celsius. It has 10 molecules of water attached to it, but above 32.8 degree it becomes dry because all the water will evaporate. So that is the reason why the solubility decreases after 32.8 degree Celsius. So the solubility curves that is seen in the graph has two uses. First is to determine the solubility of a substance at a particular temperature. So how much of the solute can dissolve in the solvent at a particular temperature can be determined by just looking at the graph. And the next is the effect of cooling of hot solutions of different substances can be found from the curves. How? Means when certain amount of temperature is decreased, how much of the crystals are going to come out from the solution can be determined by just looking at the curves. For example, when a saturated solution is prepared at 40 degrees Celsius and then it is cooled to 15 degrees Celsius, some salts get precipitated out as crystals. So that can be determined by just looking at the solubility curve that you see in the graph. Now next we move on to the effect of pressure and temperature on the solubility of gases in water. Now, if you increase the pressure on the surface of the water, what happens? The solubility of a gas in water increases, becomes more. So at any given temperature, the mass of gas dissolved by a fixed volume of liquid is directly proportional to the pressure on the surface of the liquid. Okay, this is a law which is known as Henry's law. You have to learn by heart. It is a law, so you need to learn by heart. So the mass of the gas dissolved by a fixed volume of liquid is directly proportional to the pressure. So more pressure you give, more gas will dissolve. The less pressure, less gas will dissolve. Now, for example, the solubility of carbon dioxide in water under normal atmospheric pressure is low. But when more pressure is given to the surface of the water, more carbon dioxide can dissolve in it. You have seen it as in the case of soda water, okay? Or for example, instead of soda water, let me talk about the Coke, normal Coke that you drink, okay? When it is subjected under great pressure, that is why so much of carbon dioxide is inside that bottle, that when you open it, you can hear the sound by which the fizz sound by which carbon dioxide escapes into the atmosphere, because it was under pressure. And you'll see lots of gas bubbles coming out, because what happens? The pressure on the surface of the liquid suddenly becomes less. Okay, now next is temperature. We already saw an increase in temperature of water causes decrease in solubility of a gas, because when we heat, when we boil, what happens? It will expand and the gases will escape from the water. So when we boil water, water will lose its taste. It becomes flat. So why? Because the taste of water is due to the gases that you find in it. So when you boil it, what happens? The gases escape from the water, leaving it tasteless. And a decrease in temperature of water increases the solubility of gases in water. That is why chilled soft drink bottles give out more fizz. Okay. Now, next we move on to crystals and crystallization. Now, what is a crystal? Now, a crystal is a homogeneous solid, has the same composition throughout, homogeneous, and it has a definite geometrical shape. Take one cube of sugar or sugar crystals and just look at the shape. It has a definite geometrical shape. It has symmetrically arranged smooth plane surfaces which meet, forming sharp edges. And what is crystallization? It is the process by which crystals of a substance are obtained by cooling of hot saturated solution. Now, supposing here you add sugar. Supposing here you have 4 spoons of sugar. Okay, this makes a saturated solution. Okay, you put 1 more spoon plus 1, it will not dissolve. You heat it, it will dissolve. When you cool it, this 1 teaspoon of sugar will come out as crystals. Okay, so all crystals of pure compound are similar in shape, but those of different compounds may be of different shapes. Okay, some of the shapes is first is cubic, as in sodium chloride cube. Okay, they are in the form of cube. Rhombohedric, as in the form of copper sulfate, they're cubic. This is rhombohedric. Then next is ferrous sulfate is octahedral, and potassium nitrate is prismatic. So these are the various shapes. In nature too, there are several crystals which can be recovered from the earth as minerals, like common salt, potassium nitrate, ruby, sapphire, diamond. All of these are crystals. Okay, and some have beautiful colors. So the colors are due to traces of water or impurities present in them. For example, you know the color of ruby is red. Okay, so the red color of ruby is due to a trace of mercury oxide present in its crystal. So mercury oxide is the impurity that is present in ruby. Now in the laboratory, how do we obtain crystals? You already know, by cooling a hot saturated solution. Next is by slowly evaporating a saturated solution. Solution is saturated, you heat it to remove some water. So that is how you obtain crystals. Next is by cooling a fused mass, and next is by sublimation. So these are the 4 ways by which you will get crystals in the laboratory. Okay. Now there is a method to prepare large crystals of copper sulfate. Okay, so for this what you have to do is, it is very simple. Take a look at this diagram. First we have copper sulfate solution which is saturated, okay, and the temperature is 80 degrees Celsius. Now then we filter it. Now the filtrate is cooled and it is left for a day. The next morning what happens, you'll see tiny crystals, okay. From here you'll see tiny small crystals coming out. These are the crystals of copper sulfate. Now from here we take one crystal, okay, and then we suspend it here with the help of a thread, and we take a fresh copper sulfate solution. Okay, this was when we formed the crystals. Now we hang it here and we cover the beaker with a piece of paper here. We cover it with a piece of paper so that dust does not get inside, and we leave the beaker undisturbed. And what will you see? You'll see magic. The tiny crystals will start growing. It will grow bigger in size. It will become bigger and bigger. So the small suspended crystal served as the seed crystal. Okay, so after a few days you'll see the crystal that you had hung with the help of the rope becomes very big. So this process is known as inducing crystallization, by adding a crystal of pure substance into its saturated solution, and this process is known as seeding. And we covered it with paper so that dust particles do not get in, because if any dust particle gets inside this solution, what will happen? Crystals will form around the dust particles as well. Okay children, this is all for today. Now for your assignment which you will be submitting on Saturday, please do on crystals and crystallization. Define what is a crystal, define crystallization, and write down about its different shapes, okay, and also how crystals are obtained in the laboratory, and the experiment to prepare large crystals of copper sulfate. Write down the experiment and do this diagram as well. So till then children, stay safe. God bless you.